Here we are thinking about learning target number 10, really similar to number 9, just this time looking at convergent plate boundaries, right? So we're still thinking about the same details, what's going on with earthquakes, what's going on with volcanoes, and then label up a couple key features. So looking at the helpful hints, there's a couple questions you can think about as you explain out what's happening. But again, all this is coming right from our convergent boundary notes. So because we know at a convergent boundary, we have two plates merging together. And in our picture here, both on our notes and our learning targets, this is an ocean and continent boundary. And we know that because one, we see the ocean water here, but also two, this piece of crust is thinner than this one. We see the different colors representing basalt and granite. So we know this is our oceanic crust. And we know this crust is more dense than the continental crust. So what we see happening as these two plates merge towards each other is we see the more dense piece of crust sink down into the asthenosphere. So we should be able to label that up. And we know that that sinking is happening because of the forces within the asthenosphere, right? Our slab pull is slowly moving that tectonic plate downward underneath the less dense continental crust, which is essentially floating, if you will, on top. So as that oceanic crust is being pulled down, we are getting a feature known as subduction zone. And that subduction zone is this whole area right here. And this subduction zone is really the key to all of the features happening at this boundary, both the earthquakes and the volcanoes. So subduction is a key word in your description. It should be in both of these explanations. Subduction zone is the spot where that old crust is pulled downward. And as it's pulled downward, you can kind of see what starts happening to it is it's surrounded then by that red bubble, which hopefully looks familiar. This is the magma. And that magma is formed from the melting of that subducting plate. Because as that crust gets pulled further and further down into the earth, we know it gets superheated, getting closer to the core, and therefore it begins to melt. So we want to label it as old crust being destroyed. I'm going to zoom way in for this one. So that crust gets destroyed by getting heated, being pulled down into the mantle. That crust is being destroyed, turning into magma. And that magma, along with the movement of subduction, is what fuels the earthquakes and the volcanoes at this boundary. That magma, over time, starts to collect up and can work its way up to the surface, creating this big time feature up here, volcanoes. That magma rises up, erupting out of the surface. So we know volcanoes exist here, but our question, just like on Divergent, is where? What is their location relative to the boundary? Remember, the boundary is the spot where the two plates meet. So if I was labeling that up on my map, it'd be somewhere in here. When I look at that location, I notice that those volcanoes aren't right where the two plates come together, but they're rather off the boundary line. And these are some of the most explosive type of volcanoes. So I've got volcanoes off the boundary. As far as earthquakes go, that should be a no-brainer. We know that there's motion at this boundary. These plates are moving together. So any sort of movement is what creates our earthquakes. So yes, we know earthquakes are happening. In terms of location and depth, we have to think about, well, where is the crust moving? That's what creates the earthquake, the movement of the crust. So we're thinking about earthquakes, again, being marked with an X. I'm going to pick a bright color again. Those earthquakes are happening anywhere where that crust is moving. So as it's being forced down, that oceanic crust more dense being forced down underneath the less dense continental, I'm getting earthquakes all along my subducting plate. And the fact that they're happening all along the plate gives me the information I need for both location and depth. Again, location, we're looking at the boundary right here. So when we think about the boundary line, I definitely do have some earthquakes happening right on the boundary. I can see them right where the two plates meet. However, that's not my only location, right? I do see, as we look further and further down the plate, when this earthquake occurs, it's going to radiate up to the surface, similar to the volcanoes. This is considered to be off the boundary. So I'm going to see earthquakes happening everywhere at this boundary, both on, in the middle, and farther away from that boundary line. Same thing with depth. Earlier in Divergent, we saw them happening mostly right on the surface. They were shallow. But here I'm getting earthquakes right on the boundary, shallow depth, medium, a little further from the boundary, and the deepest happen the farthest away from the boundary. And again, it all goes back to that subducting plate. I'm getting the earthquakes happen everywhere along that boundary. So when you're thinking about your description, why do I see earthquakes happening every depth, both places on and off the boundary? Again, it all has to do with that subducting plate. Describe how and why that plate's going in. Earthquakes are happening anywhere where that plate moves, so they're going all along that subduction zone. The further it goes down, the deeper those earthquakes occur. And because they radiate straight up, they're happening far off that boundary line. Same thing with volcanoes. The melting only occurs at the base of that subduction zone. I don't have melting here yet. So my volcanoes aren't close to the boundary. They're farther away because of the subduction zone melting at the bottom. So you're describing that using your details, and you can get some helpful hints from this section as well. Okay, you do have a few things to label, just like our picture on here, but notice that this image is flipped around. Continental crust on the right versus continental crust on the left. And I already kept these arrows in the picture, so you're just labeling up these features along with your forces inside the mantle.